So up until this point, we've been taking values from spreadsheets and plugging them into distributions and expressing them as area of shapes. Now we can take this idea, or we can take these techniques a little further and grab positional data from the world in latitude and longitude and map that into pixel space. 0 to 1920, 0 to 1080. So we got a brand new scene. Default. All right. I have made a very simple data set, which is in Notion. It's over here. And what this is the places I've lived, their names, their latitude, longitude, and how long I've lived there. So let's first get the spreadsheet into Cavalry. Right click, import. Alrighty. Great. All right, and let's see. To start, we're just going to do latitude and longitude. And as always, you have to name stuff. Now you really have to name stuff, or else you will be lost. Okay. So here's how this works. We need to remap the numbers. And from what to what. So that's where these little graphics come in that I have. Okay, so positions on Earth are denoted in latitude, which are the wide kind of horizontal bands, and those are marked from 0 at the equator to 90 at the North Pole, negative 90 at the South Pole. And then longitude, so lat as in wide, longitude as in long, are the vertical bars, which denote where east and west you are on the globe. 0 somewhere in England, and those are noted from 0, negative 180 in one direction, positive 180 in the other. Okay, now we are going to take those numbers and map it to a equirectangular map, which is basically treating the map as a flat, treating the globe, sorry, as a flat graphic, right? Like flattening it out. Now, why? Well, it is far and away the simplest way to do things. It's very similar to some default projections in Cinema and Maya. It is the easiest way to translate what is circular to a two-dimensional space. So that's the good, the pros. The cons are when you take a sphere and you flatten it out, you are distorting the map, okay? And any projection that doesn't start cutting up, well, actually, any projection has a certain degree of distortion. But if you want to try to keep it without breaks in it, like like an orange peel, like you start having to cut things. If you want to keep it even, there's going to be some distortion. And in this particular projection, there's very little distortion along the equator, but as you get closer and closer to the poles, there's more distortion. So distortion is just a fact of life, and we can pick different projections to do different things, but that is definitely outside of the scope of this class. For now, we're going to use equirectangular. It's very popular. You can do a lot of really great stuff with it, and it is the thing you see most often because it is the simplest to set up. So let's do it. So what we have, if we're looking, if we go back to cavalry, is the source. So this is the longitude. Longitude goes from negative 180 to positive 180. And the minimum is 0. And the maximum is 100. So let's see, how do we want to do it? The way cavalry is set up is we have our 1920 by 1080 frame. And how it works is the origin is right in the middle. So we can either go from 0 to 1920 in the X, or 0 to 1080 in the Y, or we can do something like this. So we can say negative 960 to positive 960. All right. So that means the line that goes through England is going to be right in the middle, and we're mapping it from longitude to the X pixels in our canvas. Let's do the same thing with latitude. So we're going to remap it. The minimum is negative 90. The maximum is 90. The minimum is negative 540. The maximum is positive 540. All right. Now, let's see how this is working. So I'm going to make a dot. I'm going to make it pretty small. Make it a little easier to see. Background a little darker too. All right, so with this dot selected, the duplicator, we're going to set the distribution to point. Our count will be eight. Okay. All right. Now the shape position X. So the longitude is going to go into the shape position X, and the latitude is going to go into the shape position Y. Pretty neat. Now, I can tell this is working because I've set this up. So, if we look at these here, we got Sarasota, so that's Florida. We got San Diego, that's over there, and then all these places on the East Coast. And if we want to see this relative to the world, I have included a asset for you, which is called World Map 01 SVG. It's a vector world map that has been mapped out as an equirectangular. I'm going to drag it in here and look at that. That is Fantastic. All right. So we have taken position on the world and put them accurately on a map. All right. So the next thing I would do, especially for this, is I don't think you should do the math in the spreadsheet because some of the other data sets I've shared with you have thousands of fields. So we need to revisit how we plug numbers into area of a circle. We're going to do circles for this one. So it is the square root of our number divided by pi. All right. So step one is get our number in here. So we're going to grab this and I'm going to rename this years. Okay, and then we need some math. Command period math. So years. We are we'll do a number range. Let's see. Biggest number is 18, where I grew up. Leave this alone for now. Grab this, plug it into math first. You click on math, and we want to divide. Divide by what? Pi, which is 3.14. Maybe we'll even rename this. Divide by pi. And then we need another math. This one is going to plug into first term. This one is the root. And then this root gets plugged into our radius. Right, if we zoom in, see that's Bristol, the longest. I've been in Sarasota about as long as I lived in San Diego. And maybe we want to turn the opacity down so we can see there's a lot of places in the Northeast.